Today we are going to start a new lesson, Unit 1, Mass and Weight. We are going to know the difference between the mass and the weight. First of all, our word, anything in our word is divided either to living or non-living. Living like human, animals, and plants. And as we know that the building unit of anything living is cell. What about the non-living? The non-living we have solid, liquids, and gas. And the building unit of the non-living is molecules. Okay? Right. I can give another word for the non-living instead of the word non-living. I can give it the word matter. So anything which is non-living, I can call it matter. I can call this marker matter. The board is a matter. Okay? So anything which is non-living, I can call it matter. What is the definition of matter? Matter is anything having mass and volume. So anything that I can measure as mass and volume, I will call it matter. First, we are going to talk about the mass. What is the mass? Mass is the amount of matter in an object. What is the meaning of this? If I want to know the mass of an object, so I need to know the amount of matter in this object. And as we said before, matter has three states: solid, liquid, and gas. So if I want to know, for example, the mass of this chair, but I want to know the amount of wood used to make this chair. If I want to know the amount of mass of the bottle, so I need to know the amount of water which is in the bottle. And what about if I want to know the mass of a balloon? I want to know the amount of air which is in the balloon. So the mass is the amount of matter in an object. Again, it is the amount of matter in an object. Then, how can I measure the mass? To measure the mass, we use something called balances. To measure the mass, we use balances. Do I have only one type of balance? No, I have different types of balance. Why? Because to be able to measure different things. For example, if I want to measure my mass, I will not use the same balance if I'm going to measure the mass of a ring. So I have to use different balance. What are the tools used for measuring the mass? We have 4 tools to measure the mass. Number 1, balance scale, sensitive 2-arm scale, 1-arm scale with a pointer, and digital 1-arm scale. First, we are going to talk about the balance scale. The balance scale is the balance that we took in Junior 4, but we used to call it common balance. Now in Junior 6, we're going to call it balance scale. What does it look like? It looks like this. It has 2 pans. We are going to put the loads on one pan. What are the loads? These are iron cubes with specific mass written on it. For example, 1 kilogram, 2 kilogram, and so on. I'm going to put my iron load here, and I'm going to put the thing that I want to measure its weight, its mass on the other pan, like the watermelon. And I will start to add loads until both pans are on the same line. So here I have 3 kilograms, so the mass of this watermelon is 3 kilograms. Okay? So the balance scale is used to measure large masses like watermelon, fruits, vegetables. Okay? So it is used to measure large masses. vegetables in the street. What about sensitive two-arm scale? Sensitive two-arm scale. Sensitive means it is used for measuring small masses, very small masses. Like what? Like if I want to measure the mass of a ring, can I put it on the balance scale? No. What will happen if I'm going to put my ring here? Nothing is going to happen. So I will not be able to measure its mass. So if I want to measure small masses, I will use the sensitive two-arm scale. Why two-arm? Because it has two panels. Okay? So it is used for measuring here small masses. Only the rings or only the jewelries? No. I can also use it in measuring, making medicine. They need to put very small amount of the medicine. So how are they going to measure the mass? By using the sensitive two-arm scale. What about one-arm scale with a pointer? One arm means that it has only one pan. With the pointer here, I have a pointer to show me the mass. Here I have numbers. I'm going to put my weight here, the thing that I want to measure its mass here, and this pointer will show me the mass. Where can I see this type of balance? I can see it at home, okay? Maybe at the kitchen if your mom is making anything and you want to measure the mass to add the recipe. Also maybe at the doctor if you are going to measure your mass. So it is called one-arm scale with a pointer. One-arm scale with a pointer. Okay? Then we have one-arm digital scale. Again, one arm. So I have two balances having the word one arm. One arm scale with a pointer and one arm digital scale. The word digital means that it doesn't have a pointer like here. It has what? It has numbers. It will write me the number directly without a pointer to show me the mass. The number will be seen here. Where do I use it? You can see that this one is more advanced. I can use it for measuring either small masses or large masses. You can see if you are going to buy jewelry, the man is going to put the jewelry on the balance to measure it, so it gets small masses. Or I can also see it in Carrefour if you are going to buy some fruits and vegetables. You are going to put your thing the object that you want to measure the mass here, and the number will appear here to tell you the mass. So again, I have 4 tools for measuring the mass: balance scale, sensitive two-arm scale, one-arm scale with a pointer, and one-arm digital scale. Clear? Then we are going to move to the units. What's the meaning of units? If I want to measure my mass, I will stand on the balance and for example I see it is 40. 40 what? 40 apples? 40 bananas? 40 mangoes? No, of course. 40 what? 40 kilograms. My mass is 40 kilograms. So the word kilogram that I use after the number is to show me that I'm talking about the mass. Kilogram is for measuring the large masses. For example, apples, watermelon, bananas. I will go to the man to tell him I want 2. Can I say 2 and that's it? No, he will give me 2 apples, 2 watermelons. But if I'm going to tell him I want 2 kilograms, so he's going to start measuring 2 kilograms of apples and he's going to give it to me. So I have to mention the word kilogram. They found that the 1 kilogram is similar to what? It's similar to 1 liter. For example, they found that if I have a bottle and this bottle, its volume is 1 liter, if they are going to take it and measure its mass, they found it is equal to 1 kilogram. So 1 kilogram is equal to 1 liter. That's why in the bottle of milk sometimes you can see it written 1 kilogram or 1 liter because they are the same. masses. Again, gram is a unit used for measuring small masses. How small? They found that the 1 gram is equivalent to the mass of 1 paper clip. You know the paper clip? Okay, they found that its mass is about 1 gram. So 1 gram is equivalent to a mass of a paper clip. If I want to change from kilogram to gram, we found that 1 kilogram is equal to 1,000 grams. 1 kilogram is equal to 1,000 grams. Like I want to remember, I cannot remember in the exam 1 kilogram is equal to how many grams, how many zeros, maybe 100, maybe 1,000, I cannot remember. What shall I do? The cake has 3 places for 3 zeros. So 3 zeros. And I will write the number which is written here, there. I have 1 and 3 zeros. So 1 kilogram is equal to 1,000 grams. 3 kilograms is equal to how many grams? I will say 3 zeros. And I have here 3, so it will be 3,000 grams. Does the mass change from one place to another? No. The mass is constant. The mass is constant. What is the meaning of this? Constant means that it doesn't change from one place to another. Like what? For example, I will measure my mass. I will stand on the balance and I will find it 40. So I'm in the classroom, my mass is 40. What about if I'm going to go down to the garden? Will it be 60, for example? No, it will remain as it is, 40. But I'm going to go to my home. It will be 50, but it will remain 40, the same, 40. I'm going to go to the club, 40. I'm going to go to the moon, it will be 40. Okay? So the mass is constant, which means that it does not change from one place to another. Example, if I'm going to take these 2 markers, I'm going to see their masses and I will record it. Then I'm going to take them with me anywhere. Is their mass going to change? No. Take them to the club, take them to the moon, take them to the garden, take them everywhere. The mass will be the same. It will never change. So the mass is constant. It means it doesn't change by changing places. What about the weight? We said that Unit 1 is talking about the mass and weight. We've already talked about the mass. We need to know what is the weight. Before I start talking about the weight, I want you to think, why do we walk on ground? Why we don't fly? Okay? Why, if I'm going to throw this marker, it is going to fall on the ground? Because if this is the earth, inside the center of the earth, there is, or Allah subhanahu wa ta'ala created a certain force inside the center of the earth, which pulls everything towards the surface of the earth. This force is called gravity. Again, inside the center of the earth, there is a certain force that Allah subhanahu wa ta'ala created. We have nothing to do with it. This force attracts everything towards the surface of the earth. This force differs from one object to another. According to what? According to the mass of the object. For example, if I have this marker and your school bag. Your school bag has many books in it, so its mass will be very big. If I'm going to take the marker and the school bag and I'm going to throw them from the window, which one will reach the ground first? Of course, the school bag. Why? Because it has a very large mass. So, as the mass increases, the amount of force which is required to pull the object to to the surface will increase. Again, the amount of force which is needed to pull the things to the surface of the earth will increase as I increase the mass. What do we call this amount of force? We call it the weight. So, the weight is the force by which the object is attracted to the earth. In the weight we have only one tool and one unit. But in the mass we took 4 tools and 2 units. The weight we are measured by something called the spring scale. What does the spring scale look like? It is like this. Can you see it? This is the spring scale. This hanger is to hang what I'm going to put on, and it will go down. Can you see the numbers in here so that I can read my numbers? So if I want to measure anything, for example, I want to measure the weight of this pencil case, I'm going to hang it like this, okay? And I'm going to see the number, it is 2. 2 what? Can I say 2 kilogram like in the mass? No, because I'm not measuring a mass, I'm measuring the weight. The unit of weight is something called Newton. It is called Newton. So, the weight of my pencil case is 2 Newton. I have also a definition for the Newton. What is the Newton? It is the weight of an object whose mass is 100 grams. The weight of an object whose mass is 100 grams. What about the unit for the weight? We said that the unit for the mass is gram and kilogram. Can I use the same unit of the mass for the weight? No, of course. Because I need to know I'm talking about the mass or I'm talking about the weight. The unit for the weight is called Newton. The unit for the weight is called Newton. What is the definition of Newton? It is the weight of an object whose mass is 100 grams. The weight of an object whose mass is 100 grams. What is the meaning of this? They found that whenever I get an object, I'm going to measure the mass. If the mass is 100 grams, then after that I want to measure the weight by using the spring scale. I will find that the weight is equal to 1. Again, if I have an object and the object's mass is 100 grams, if I'm going to measure this weight by using the spring scale, I will find that this weight is equal to 1. 1 what? 1 Newton. So if I want to define the Newton, it will be the weight of an object whose mass is 100 grams. The weight of an object whose mass